This is just a quick video to illustrate that I have made a little bit of progress with the sound amplifier. Now, the story behind this is that my brother-in-law has a hearing problem and some dexterity problems. It's hard for him to, or it would be hard for him to manage a hearing aid and the tiny filters that have to be dealt with and the small batteries. And even if you got a chargeable type battery for them, it's still a little bit beyond his capability, we'll say. So my game plan is to build an amplifier that he can use these with, and that's the power amp you're looking at on the breadboard. It is powered by this power supply, the instrument on the bottom there. That 1.99 is the voltage that powers this entire power amp. And to get that kind of response out of a power amp took a lot of effort. It's a very unique design. I don't believe I've ever seen it used like that before, but it will swing to within 2/10 of the positive rail and ground rail while driving an 8 ohm load. Now, the 8 ohm load is actually two 16 ohm loads in parallel, which represent the two headphones in parallel. So what I want to do is just show you a couple of things here. That jumpy waveform, by the way, is my voice. But what I'm going to do is capture a whistle. So to do that, I'm going to do a single trigger, and you can see when I speak it triggers. So let's see what happens when I whistle. Now, I'm going to have to be quiet for a minute or it's going to trip again. Wasn't a good one. I'm going to turn it down a notch too. A little bit better, and I can come up now. The waveform is actually pretty well jumbled up, and you'd think, well, you can't really tell anything about it. But my scope lets me do a very nice thing, and that is to zoom in, which I've just enabled. Here, we see an extra screen or waveform portion on the screen has popped up, and what it's showing is between these brackets is what's being displayed down here in the main screen area. So I can actually measure that. Oops, I'm spreading instead of doing cursors. I want to do this. That'll be good. You see the bottom cursor moving? It's going a little too fast, but bring it up. And we'll switch to the other one and bring it down. And if you look at the delta right here, that's 300 millivolts peak to peak. Now, that's nothing to write home about, but that's because my input signal is low level. This is intended to work with a preamp, which would make that signal a lot bit bigger, and if I'd have whistled a little better, it would have been a bigger signal also. But what we can see looking at this waveform is some of the crossover that comes from Class B amplifier outputs right here and right here is totally absent. So I don't have crossover at low level signals, which is a good thing. That's where you don't want it. If I increase the signal input, I think you'd start to see some crossover. This was about a 1.7 kilohertz, as I recall. Actually, I can show you that. The frequency is 1.445 kilohertz in this case. So I have made progress. When I first hooked the mic up to the power amp and bypassed the preamp because I didn't have one ready for it yet, it just went crazy. And I had to use some filter techniques to isolate the input from the output. In a situation like this, often what happens, especially when you're driving a powerful load, and headphones represent a powerful load, 8 ohms, compared to small signal stuff, you often get fluctuations on the power rail, which is this red lead going back through here. And here's the mic. So it opens the circuit up for some oscillation. So I had to do some things to get that out of it, and a little bit of progress here. The next thing is to actually rebuild this entire circuit on a much smaller area, so I can add the frequency shaping circuit here and the preamp here. So a lot of work needs to be done yet, and it's got to be able to stabilize this thing with a preamp, which is even more gain. So the more gain you have, the harder it is to kind of get it stable and operating correctly. So some progress.